So this is going to be the Unit 2 honors review, and then I will be doing the 4th exam review for concurrent enrollment. So the first little bit will work for both of you, and then I will tell honors when to stop watching, and then concurrent enrollment will continue watching the video lesson. Okay, so we're asked to simplify and state the excluded values. So the first thing we do is we get everything in standard form and factor it all out. So remember with simplification, it's factor the top, factor the bottom, restrict, and then divide. So rewriting this, negative 4n squared plus 24n. And then on bottom we have our 2n squared minus 9n minus 18. So when I factor out the top, there's a greatest common factor of negative 4n. So I pull that out. So then I divide by negative 4n, divide by negative 4n. So then left would be n minus 6. Now over here we're going to have long factoring. What multiplies to be a times c and adds up to be b, because it's a quadratic, right? So it multiplies to be negative 36 and adds up to be negative 9. That would be 12 times 3, negative 12. Long factoring, so we have our 2n squared minus 12n. I meant to write minus right there real quick. Plus 3n, and then minus 18, factoring by grouping. Okay, so on bottom I have my n minus 6 and my 2n minus 3. Okay, so now that's a minus sign. So now we will go ahead and restrict first. It's really important to remember to restrict first. So whatever makes the denominator 0 would not be okay and cannot be equal to 6. Or if you set that equal to 0, you'll add 3 divided by 2, or 3 halves. And now divide out exact factors only. So those divide out, leaving me with negative 4n on top and then 2n minus 3. Alright, so it says simplify and state the excluded values. So once again, putting that top thing in standard form is going to be key here. 2x squared minus x minus 10. And then it looks like we're going to have some long factoring again, which we should be really good at by now. We have to long factor. So it multiplies to be negative 20 and adds up to be negative 1. 4 times 5, I'm doing that top part, long factoring. Alrighty, so the top factors 2b. I'm going to have my final factors right here, I think. So we will have an x plus 2 on top, and then a 2x minus 5. Factoring that denominator, what multiplies to be negative 24 and adds up to be 2. That looks like it's going to be 6 and 4, negative 4. Long factoring again. Do not get to the test and quick factor in places that you need to be long factoring, because that's missing points that is really not necessary to miss. Most of the time what we see is that people are not really good at factoring. They struggle with this test, so make sure you can factor things really well. If you don't know how to factor something, make sure you come in and get help. So on bottom I have an x plus 2 and a 3x minus 4. Restrict 4 first and then divide out exact factors. So we'd say x cannot equal negative 2 or 3, set that equal to 0, so add 4, so that'd be 4/3. And then looks like we can divide out these exact factors. So 2x minus 5 over 3x minus 4. Alrighty, there's our final answer for that one. Simplify and state the excluded values. So we're going to go ahead and factor out the top here. Guys, we have to be able to factor 2 perfect cubes. Do not get stuck here. Do not say this doesn't factor, and don't just say it's x minus 2 cubed. That is not true. We have that little way of factoring 2 perfect cubes. Cube root the front thing, we get x. Cube root the back thing, we get 2. Now we start our little thing. It's not x minus 2 cubed, people. So front times the front times the back times the back, as we know. This sign and that sign are the same. The next sign would be opposite of that. The final sign is always plus. The quadratic within two perfect cubes never factors, so I'm done there. Right here I'm going to pull out a -1 first. And then left would be x squared minus x minus 2. That's a -2. So then we would be doing what multiplies to be -2 and adds up to be -1. 1 times 2, -2. I can quick factor. So we have an x plus 1 and an x minus 2. Restrict first, then divide. There would be no restriction there. -1 is not 0. X cannot be -1 there because that would make that 0. And it cannot be 2 for that piece. And now we can divide out exact factors. So now we have on top an x squared plus 2x plus 4. And on bottom we have our -1. I'm just going to bring the negative out in front. And then we have our x plus 1. Once again, up here we're doing what multiplies to be -16 and adds up to be 0. 4 times -4, I can quick factor, so we have x plus 4, we have an x minus 4. Then noticing once again we have two perfect cubes, cube root that, it looks like we have an x and a 4. So we have our x and our 4, front times the front times the back times the back. This sign is the same as the original. The next sign's opposite. The last sign's plus. The quadratic within two perfect cubes does not factor. Restrict first. X cannot equal -4. Since this doesn't factor, it would need the quadratic formula. Therefore, it would have no restrictions. If we have imaginaries, that is, but we do here. So we would not restrict that part, and then we'll divide out exact factors. We shouldn't be missing these simplification ones, but you got to be able to factor right. Okay, so once again, same instructions. Simplify and state the excluded values. So in your head, you should be saying, when multiplying two fractions, I factor all the parts. That's the first step Ms. Christensen gave us. So factoring this will be a plus 4, a minus 4. Now once again, if you pause the video and factor that by yourself, because if you can't factor, you can't pass this test. We are going to pull out a common factor right here, so we're going to pull out a 12a. And then left would be a plus 4. We have a times sign. We're going to pull out a 6a squared. Then left would be a minus 5. And then what multiplies to be -24 and adds up to be 2. Have a final place where you put all your factors, because if you're showing work and not rewriting it in a special place, it can get messy and it can get confusing. We can quick factor, so we have I'm all of a sudden about to use x. Let's keep consistent here. So you have an a minus 4 and an a plus 6. So now when multiplying, we multiply straight across, but don't actually multiply. So everyone, think about it. I rewrite the 6a squared in front just because it's considered prettier. We have an a plus 4. This is a times sign, remember, but you do not actually multiply it out. On bottom, I have a 12 and an a. Then I have an a plus 4, a minus 4, and an a plus 6. We would restrict first. So a cannot equal 0 for that piece. Don't say -12. I always have people saying -12. 12 times -12 is -144, which would be okay. It can equal -4, 4, or -6. And now dividing out exact factors. 6 and 12 divide out to become 1 and 2. A squared divides out with a and becomes an a on top. So then left on top, it looks like it's just a times a minus 5. Make sure you use parentheses. Left on bottom was a 2 and an a plus 6. It would not be incorrect to multiply that stuff back together, but factored form is just as good as standard form, so why do extra work? And I make sure I circle my restrictions since that was in the instructions to do so. Okay, when dividing fractions, you have to remember that the first step is similar to multiplication, factor all the parts. So I'm going to show my work down here and rewrite the factored part here. So factoring this piece, well, multiplies to be -2 and adds up to be 1. 1 times 2, -1. We can quick factor, so we have an x plus 2 and an x minus 1. Now factoring this is going to take long factoring. What multiplies to be -6 and adds up to be negative 5. 1 times 6, negative 6. Long factoring, 3x squared minus 6x plus 1x, and then it looks like minus 2. Factoring by grouping. Pulling out a 3x, left is x minus 2. Pulling out a 1, left is x minus 2. That's a plus 1. So we now have x minus 2 here, and a 3x plus 1. Then we have to factor this. Looks like it's going to be long factoring what multiplies to be. So I just factored that. Now I'm doing this. What multiplies to be negative 3 and adds up to be negative 2. 1 times 3, negative 3. Long factoring again. 3x squared minus 3x plus 1x. And then we have a minus 1. Factoring by grouping. So we'll pull out 3x. Left is x minus 1. Pull out positive 1. Left is x minus 1. So this, we have a big division sign. And then this piece just factored to be x minus 1. And 3x plus 1. And then we have a divide sign. And then right here is going to be quick factoring. What multiplies to be 14 and adds up to be negative 9. 7 times 2, negative, negative. I can quick factor. So x minus 7 and x minus 2. Now remember, with division, you do have that extra place to restrict. I've got to restrict here, here, and here. So let's just write our restrictions right here real quick. X cannot be for this piece 2. For this piece, negative 1/3. For this piece, 1. For this piece, negative 1/3. I've already listed it. For this piece is 7. And 2. Alright, so we have a couple restrictions there. Now dividing fractions is easy as pie. Flip the second fraction and multiply. We have an x minus 7 and an x minus 2. Divided by, and we have an x minus 1 and a 3x plus 1. Now multiply straight across, but don't actually multiply. So I'm just going to go ahead and extend my line and just know that these are multiplication signs, so it would be okay to divide across them. So now we'll divide out exact factors. It looks like x minus 2 and x minus 2, x minus 1 and x minus 1, and it looks like that is it. So left on top was x plus 2 times x minus 7. On bottom it looks like we have a 3x plus 1, and then that was it, squared. So there would be our final answer. So with division, you just can't forget that extra restriction, which is different than multiplication, where you only have to just restrict the two denominators. Alright, so subtraction, you have to switch your mindset. You'd say with subtraction and adding, the only thing I factor is denominators. So we have x squared minus 10 over x minus 2, x plus 2, minus 3 over x minus 2, x plus 2. And you'd say I get a common denominator. Well, let's restrict, so x cannot be 2 or negative 2. Then you get a common denominator, which is done. Now we can combine the numerator. This is a subtraction problem. So combine like terms in just the numerator. Guys, look, the numerator has this. X squared minus 10, and then we have a minus 3. Combine like terms there. That's x squared minus 13. And then that's all over the x minus 2 and x plus 2. So now you're at your answer part. You say, this is my answer. Does my answer simplify? Factor the top, factor the bottom. The bottom should already be factored if you do these steps correctly, and then you will restrict and divide. So we've already restricted. Our top will not factor. What multiplies to be negative 13 and adds up to be 0, nothing. So if it doesn't factor, nothing will divide out. So when subtracting fractions, we factor our denominators only. Very important to remember. Multiplies to be 10 and adds up to be negative 7. 5 times 2, negative, negative. We can quick factor. Rewrite it as 3n over n minus 5, n minus 2. Then we have a minus sign. Now yes, a lot of times I make it a plus and put my negative up here. So plus negative 2n, and then on bottom, what multiplies to be 15 and adds up to be negative 8. 5 times 3, negative, negative. I can quick factor. So we have an x minus x, and same thing, but you know, it's a variable. We should probably stay consistent so we don't get confused. So n minus 5 and n minus 3. So your first step is to, since it's a simplify and restrict, I would restrict now. N cannot equal 5 or 2 or 3. So I just looked at my denominators and restricted. Now we need a common denominator. This one has an n minus 5, so does this one. We're all good. N minus 2, this one doesn't have an n minus 2, so it needs one. This one does not have an n minus 3, but it needs one. Now, right now, you're going to ignore the denominators, but not permanently. Don't get this confused with solving. So sometimes people will then cross out the denominator. This is not an equation. It doesn't have an equal sign. Our denominator is still there, but essentially for right now, we are going to ignore it, and we're going to focus on the numerator. So remember that what our next step is after we get a common denominator, multiply out and combine like terms in the numerator. So now we're just looking at the numerator. We have 3n squared minus 9n. We have a plus sign. Don't multiply the whole thing out. That's a plus sign, not a multiplication sign. So then we have minus 2n squared. And then it looks like we have plus 4n. So combine like terms before you put your denominator in. Then do not put your denominator in yet. Combine like terms first. It will prevent you from doing things that are not good. So, or make errors. So 3n squared minus 2n squared is 1n squared. Then we have a negative 9n plus 4n, so that's minus 5n. And that's all over. We have an n minus 3, n minus 5, and an n minus 2. Notice I only put the denominator back in once I have combined all like terms in my numerator. So then we would be able to, after our answer, we would just say, does our answer simplify? So back to the top. Back to the bottom, which with addition and subtraction, it should already be factored. Restrict first, then divide. We've already restricted, so our restrictions are right here, so I would circle those, and then we would divide out exact factors. So our final answer would have been n over n minus 3, n minus 2, and then our restrictions as well. Okay. So this next one here is addition. First thing you do is get a common denominator. Once again, with subtraction and addition, only factor the denominators. What multiplies to be negative 24, and adds up to be 5. It's going to be 8 times 3, negative 3. We can quick factor. So 3y plus 2 over y plus 8. And y minus 3. Then it's a plus sign. So plus signs are actually the easiest ones to do. Common denominator, what multiplies, well, sorry, not yet. Factoring this piece, what multiplies to be negative 32 and adds up to be 4. So that would be 4 and 8. Negative 4. Yep. So then we quick factor it to be y minus 4 and y plus 8. Then you'd say, okay, I'm going to restrict, because it says simplify and exclude your values, so y cannot equal negative 8, 3, 4. So then get a common denominator. This one needs a y minus 4. Put parentheses around two terms. This one needs a y minus 3. So now you'd say, okay, I focus now only on the numerator and distributing out my numerator. 3y squared plus 2y minus 12y minus 8. So that would be 3y squared minus 10y minus 8. Then we have a plus sign. Then we have a plus sign, and we have 7y minus 21. So combine like terms. Do not write in your denominator until you combine all like terms. Like, I can't stress that enough. 3y squared. Negative 10y plus 7y is negative 3y's. And then we have minus 29, it looks like. And then that's all over y minus 4, y plus 8, and then a y minus 3. Now, we got to be really careful and pretty, what's the right word? We need to check to see if this quadratic on top factors. So there's not a greatest common factor, but let's see if there is an overall factor, meaning what multiplies to be a times c. So negative 29 times 3. So multiplies to be negative 87 and adds up to be negative 3. So I would just keep track, since I don't know them right off possibly, I would just keep track of what I have done. So I would do this amount on my calculator here. Okay, I'm sorry, you've just gotta be really diligent, so, meaning don't give up. I'm at 87 divided by 19 right now. It still hasn't wrapped back around, so I know that, meaning I haven't got clear to 29 yet, so I gotta keep going just to make sure, because we don't want to give up too easy and just miss it, you know. So I'm at 21. We're almost there. We almost will know it doesn't factor, but we better be sure. Almost there. Yep, so it doesn't factor. So I got all the way to 29 and then it was 3, so I've already listed that one, so that's when I know I'm done. So we have our restrictions, and then since it didn't factor, it doesn't simplify anymore. I'm skipping around on purpose because that's how the test is going to be. So now I'm back to divisions. You'd say with dividing and multiplying, I factor all the parts. So 2x plus 1 doesn't factor. What multiplies to be 28 and adds up to be negative 11. 7 times 4, negative, negative. It quick factors to be x minus 7, x minus 4. Notice you've got to know the steps, and if you do, it's not that bad. So times by 3 and then x minus 4. So I factored that as I flipped it. Then I'm doing this part, I'm factoring what multiplies to be 4 and adds up to be 4. 2 times 2, I got a long factor. 4x squared plus 2x plus 2x plus 1, factoring by grouping. So I'll pull out a 2x, then left is 2x plus 1, factor out a 1, and left is 2x plus 1. I also could have recognized that that has 2 perfect squares, but honestly, most of you should just probably do it the long way. So then we have a 2x plus 1 times 2x plus 1. Okay, now when multiplying fractions, it was actually division. So don't forget, with division, we got to restrict here, here, and here. So that would be restricting here, here, and here. So let's write out our restrictions. X cannot be 7, 4, 4. Negative 1/2 and negative 1/2. So there's our restrictions, and now we can divide out exact factors. Because when multiplying, we multiply straight across, and just remember, I just kind of extend the line, and then I remember that these are really multiplication signs. And then if you'd like to write 3 in front, scribble it out and write 3 in front, but understand that's multiplication. So we can divide across multiplication signs, so those divide out, those divide out. So left on top was a 3, and then on bottom was an x minus 7, and a 2x plus 1. Okay, so this would be a complex fractions. That just means we have a lot of stuff to simplify. There's fractions upon fractions. So remember, with something like this, you would just focus. It's really just 3 problems within one. Literally just focus here and just simplify that first. So if you need to, on your paper, cover up this and say, when I'm subtracting fractions, the first thing I do is get a common denominator. This one has an n squared, it needs an n squared. So I times the top and bottom by n squared. This one needs an n squared. So once again, just focusing on the top. The next thing when adding and subtracting is multiplying out, dividing like terms in your numerator. N squared times 1 is n squared. We have a minus sign. We have an n squared. Because n squared times 1 is n squared. And that's all over the common denominator of n squared, divided by, and then right here you'd say, now I'm just focusing on a new problem. Guys, it's just another problem. It's very basic subtraction problem. So you'd say I need a common denominator, n over n, m over m. So numerator will become n minus m, and that's all over the common denominator of nm. Then I'm not asking you to, I'm just saying simplify, so notice I'm not asking you to restrict. So now you can say dividing fractions is easy as pi, flip the second and multiply. So nm, and then n minus m is on bottom. So then this is a multiplication problem. What do we do with multiplication? Factor all the parts. So if you factor this, you'd say that factors, because it's 2 perfect squares, so that would factor to be n minus m and n plus m. 2 perfect squares, and the middle term canceled out. Conjugate factors, if you'll remember. Then we have an n squared m squared. We have an nm on top, and then n minus m. So now we're multiplying straight across, so we can just extend our line, and we can divide across. These are multiplication signs because we multiply straight across, so we can divide across multiplication signs. n divides out with n squared, m divides out with m squared, being m and m on the bottom, and then these divide out. So my final answer would be n plus m over nm. So it's not that it's any harder, it's just it's 3 problems within one. So you gotta be really careful as you simplify them. Let's do another one of a little bit more advanced caliber. So looking at this, you'd first say I'm gonna focus on the top. When adding fractions, I have to I factor my denominator. So literally, just focusing here. So rewrite your problem. You'll say z squared minus 2 over that factors to be z plus 2, z minus 2. We only factor our denominators when adding and subtracting. Then we have plus 7 over z minus 2. Then you say, okay, I'm going to get a least common denominator now because I want to make this simplified by putting it together, but I can't put things together unless they have a common denominator. So z minus 2, z minus 2. So then the next step is to combine like terms in your numerator. So we have z squared minus 2 plus sign. We have 7z minus 14 as I distribute it. So on top we have z squared plus 7z minus 16, and that's all over the common denominator of z plus 2 and z minus 2. Now I'm just going to circle that for a second so I can remember that that's what my top simplified to be. I'll write myself a little note, top. Okay, now just focusing on the bottom. So you'd say, okay, I need to get a common denominator, but I don't know what the common denominator is unless I factor the denominators. So I have z squared plus z minus 24 over 2 perfect squares, or do what multiplies to be negative 4 and adds up to be 0, 2 and negative 2. So then we have a z plus 2, a z minus 2. Then we have minus 2 over z plus 2. Common denominator. It looks like this one needs a z minus 2. Then you'd say, okay, the next step is to combine like terms in the numerator. So I have z squared. I have plus, I wrote 2 plus signs. I'm like, what is that? So plus z minus 24, and then careful, this is actually plus negative 2, so that'll be negative 2z's, and then it will become plus 4. So combining like terms in the numerator, so in my bottom I'm going to have z squared minus 1z, and then I have minus 20, and then that's all over the common denominator of z plus 2 and z minus 2. So now from there, you'd say dividing fractions is easy as pie. I can now flip my second fraction and multiply. So this on top I better plug this in real quick. So I'm going to flip and multiply, and then remember when multiplying I factor all the parts. So we'll multiply to be negative 16 and adds up to be 7, nothing. So that piece doesn't factor. So we have z squared plus 7z minus 16 over z plus 2, z minus 2, then we have a times sign. Now on top, we're going to have a z plus 2 and a z minus 2. Because I'm flipping, so now this part's on top. So now I have z plus 2, z minus 2. Once again, because I'm taking and flipping. And then what multiplies to be negative 20 and adds up to be negative 1, 5 times 4, negative 5. I hope I didn't make an error somewhere, but if I did, hopefully you're catching it, and that's great if so. So then z minus 5 and z plus 4. So then remember when multiplying straight across, well, it didn't ask us to restrict, so we can just start dividing out things that can divide out. So then nothing more divides out, so that can happen, but I don't know if I made an error and that's why nothing more divided out, or if I did it right and it's just, it is what it is, because that does happen often, that nothing ends up dividing out more. But I don't know if I made an error and this really isn't a 7 or something, but I think I did it right. So that would be our answer, because if the top doesn't factor, it won't divide out with anything on bottom anymore. Okay, so once again, a complex fraction. So the top is simplified. The bottom, though, needs a common denominator. So the first thing when subtracting fractions is to factor our denominator. So this becomes x minus 5x plus 5. If you don't know why, pause the video and do it. So then you'd say this one needs an x minus 5. Then remember, I personally, if I see a subtraction, I make it plus and I change my signs. So now the next step is to combine like terms in your numerator. So I have x minus 3 plus sign, and then I'm going to be distributing this out, so it'll be negative x cubed minus plus 5x squared. And then I'm going to have a minus x, and then plus 5. So on the top, I'm going to have a negative x cubed. I'm going to have plus 5x squared. Nope, my x's are gone. And then it looks like plus 2. And that was all over x minus 5x plus 5. So then dividing fractions is easy as pie. Flip the second fraction and multiply. So we have x minus 5, x plus 5. We're just asked to simplify, not restrict. And then we had our negative x cubed plus 5x squared plus 2. Factor all the parts. So yes, a lot of you are seeing that I probably should pull out a negative 1 and then divide each of these by negative 1. So then that would become a minus sign and a minus sign, right? Because the negative would make positive, negative, negative. Now, we wouldn't be able to factor this unless there's p over q, but really we won't take it that far on this test. So if that doesn't factor, which is cubic squared and then constant, there's not even a u substitution I could do there. So I'm going to just say that it doesn't factor. So then I'm going to divide out what can divide out, and then that's it. So we have a 2x left on top, x plus 5. Then on bottom, we have a negative 1 and x cubed minus 5x squared minus 2. So once again, the only way we could factor this is p over q, but you're not going to have to do that. What I mean by that is we haven't done that in 1010 this year either. And so in honors, you'll know what I'm talking about, but in regular, you would not. So you could, if you're in honors, you would check to see if p over q works, if there's any rational roots. But if not, we wouldn't take it any further. There would be no way to take it further. In honors, you would just say automatically, there's no method I've learned to factor this. This isn't a quadratic in form, because if it was 4-2 constant, we might have a quadratic in form, but it's not. It's 3-2 constant, so we don't know how to factor that, so we're done. Okay, so it says solve. So the first thing when solving, you have to know your steps, is to get a common denominator. So this one needs a w minus 3, w minus 3. This one needs a w. This one needs a w minus 3. So I'm looking and saying, oh, you know what? Well, this one needed a w as well then. So now you can ignore the denominator since they are all the same. It's w and w minus 3, so ignore the denominators. So now w times w is w squared. W times negative 3 is negative 3w. Then I have times 1, so that's why that stayed the same. Then I have plus 10w is equal to 2w minus 6. Combining like terms, well, it's a quadratic actually, so quadratic. We're going to have w squared plus 7w equals 2w minus 6. You'd say, when solving a quadratic, I get it set equal to 0, so I'm going to subtract 2w, add 6. So now I have w squared plus 5w plus 6 equals 0. So if you have this quadratic, now we can solve. It multiplies to be 6 and adds up to be 5. 3 times 2, 3 times 2. So then we can quick factor. So w plus 3, w plus 2. Don't say that 3 and 2 are the solutions. That's not true. Those are our linear factors, and I could quick factor. So w equals negative 3 and w equals negative 2. Now guess what? I forgot to do an important step. In the very beginning, remember, we should restrict because we have solutions that can't be. So I should have said w cannot be 3 and w cannot be 0, because look, if I forgot that, I could have missed something. Luckily, neither of these solutions came out to be extraneous, but I lucked out. So just make sure we restrict before we solve so that we don't forget what solutions we would need to throw out if we were to get them. It says solve. So you'd say, okay, to solve, I've got to factor out my denominators. So 4 over x minus 5 plus 3 over x minus 2. equals x plus 1 over what multiplies to be 10 and adds up to be negative 7. 5 times 2, negative, negative. We can quick factor, so that's x minus 5 and x minus 2. So you'd say, okay, I am going to restrict, so x cannot be 5 or 2. If we solve and we get either of those solutions, they're going to be extraneous. We would throw them out. So now we get a common denominator, x minus 2. And because we're solving, and only because we're solving, we can ignore the denominator. So now we have 4x minus 8 plus 3x minus 15 equals x plus 1. So it's just linear, combine like terms on this side. So we have 7x, 15 minus 23 equals x plus 1. So now combine your x's, subtract x, 6x, add 23. So equals 24, so x equals 4. Was that a restricted value? No. So we're good, and we could check our answers by plugging 4 back into the original and making sure we come out with a true statement. It says solve. So once again, factoring all your denominators is your first step. Multiplies to be negative 12 and adds up to be 1. 3 times 4, negative 3. So we have 7 over y minus 3. Y plus 4 minus 4y over what multiplies to be 12 and adds up to be 7. 3 and 4 positive. We can quick factor, so we have a y plus 3, a y plus 4 is equal to 6 over what multiplies to be negative 9 and adds up to be 0. 3 times negative 3. So then that would be y plus 3, y minus 3. So you'd say I'm going to make my restrictions now. So y cannot equal 3, negative 4, and negative 3. So common denominator, this one needs a y plus 3. This one needs a y minus 3. And this one needs a y plus 4. So ignoring the denominator now, I just crossed out half the numerator. The denominator now, so then I have 7y plus 21 equals, not equals, but minus sign. Minus sign, looks like that's going to be 4y squared plus a negative 4y squared, and then a plus, because a negative and a negative is positive, don't forget to distribute that negative. And that would be plus, that's where most people make their error. They don't distribute the negative. So you could have went like this, and then you would have probably been less likely to make the error. Plus 12y, and that's equal to 6y plus 24. So you have a quadratic. You need to get it set equal to 0 and solve by factoring. So we have a negative 4y squared, 7y plus 12y, 7, 8, 9. That's 19y. 19y plus 21 equals 6y plus 24. So we got to get it set equal to 0, right? So we have negative 4y squared, and then we have subtract 6y over, and subtract 24, subtract 6y, and subtract 24. So then that's 13 plus 13y's, and then it looks like it's going to be minus 3. And equals 0. So then I'm going to actually pull out a negative 1 from the get-go. So 4y squared minus 13y, and then it'll be plus 3 equals 0. So because I'm solving, that negative 1 won't matter. It multiplies to be 12 and adds up to be negative 13. 1 and 12, negative, negative. Long factoring. Drop 4y squared minus 12y minus 1y minus plus 3. Drop and break, and then factoring by grouping. So I'm going to pull out a 4y, then left is y minus 3. Pull out a negative 1, y minus 3. So we have 4y minus 1. And then it looks like we have a y minus 3. So my two solutions are y is equal to 1/4 and y is equal to 3. There are my two solutions. Were either of those restricted values? Yep, 3 was a restricted value. So that's extraneous, so we only keep 1/4. Okay, that's pretty good. I think we get the picture here with solving. So, yeah, that's the end of the honors review. If you are an honors student, you can now stop watching. If you are in 1010, we have to do some more here, so we'll keep going. Divide with long division. So remember, you'd set up x squared plus 2x plus 5 on the outside of our house. 2x to the 4th minus 11x cubed plus 8x squared minus 22x plus 144 under my house, and then bulletin point. You divide your leading terms if you can remember. So we have a 2x to the 4th divided by x squared, which is 2x squared, so that's a part of our answer. 2x squared, then remember we multiply it down here, here, and here. So 2x squared times x squared is 2x to the 4th. Then 2x squared times positive 2x is positive 4x cubed. Then we have positive 2x squared times positive 5 is positive 10x squared. Remember the most important step, change the sign. Add straight down, combining like terms. People get freaked out if there's things that can't be combined under here, like, but you just literally, just combining like terms, like combine apples with apples, oranges with oranges. So these are gone, minus 15x cubed, and it looks like it's going to be minus 2x squared. Then we're going to have minus 22x's, and then plus 144. Bulletin point, starting over, leading term, negative 15x cubed, divided by leading term x squared. If you look, leading term. So that's negative 15x. So minus 15x, then I'm going to distribute. So negative 15x times x squared is negative 15, negative 15x cubed. And then negative 15x times positive 2x is negative 30x squared. Then we have negative 15 times 5, which will be negative 75x. Then important step, change the sign, change the sign, change the sign. Combine like terms, adding straight down. These go away, so then we have plus 28x squared plus 53x plus 144. And now we're starting the process over again. Bulletin point. 28x squared divided by x squared is equal to positive 28. So now we have a plus 28. And we distribute. So we have 28x squared. And it looks like we have plus 40, 40 plus 16, so that'd be 56 x's, and then it looks like we have plus 140, then change the sign, adding straight down. These are gone. This becomes negative 3x, and then we have plus 4. Now look, if you went and did negative 3x divided by x squared, it doesn't divide anymore perfectly, so that's our remainder. So remember how we write our remainder. We'll say that's our answer, and then since we'll add our remainder on, so plus negative 3x plus 4 when we divided by x squared plus 2x plus 5. Just remember that's how we write it. So, long division. It always works out the same way with those same steps. Now we'll do synthetic division. So synthetic division is much quicker, and we know we would use our 0. So x equals 3, we're going to be using 3, and we'll set up our little house. Put in your coefficients, making sure you're not missing anything. 4, 3, 2, 1, constant, very important. 3, negative 5, negative 21, 17, 25. We add straight down. 3 plus nothing is 3. Multiply up, 9. Add straight down, we get 4. Multiply up, 12. Add straight down. So then we have negative 27, and we add straight down, we get negative 10, and then negative 30, and we add straight down, and we get negative 5. So then degree 4 was divided by degree 1, making it degree 3. So 3x cubed plus 4x squared minus 9x minus 10, and then our remainder is negative 5, so minus 5 when we divide it by x minus 3. So that'd be our answer. So with this next one, notice we are missing, so we'll use 8. Set that equal to 0 and solve. So 8. Now notice we're missing 3 and degree 1. A cubed is gone, and 0a is gone. So we have a 1, a 0, a negative 65, a 0, a 55. That is so important to remember. So you don't want to be able to do synthetic division and get it wrong just because you forgot that. Just making sure I'm doing this right. I'm going really quick here. So degree 4 divided by degree 1 is degree 3, so this is 1a cubed plus 8a squared minus a. What did I miss? Oh, it was 4. Oh yeah, 4 divided by 1 is 3. Do I have something extra here? 3, 2, 1 constant. Oh no, I don't know why I'm freaking out. And then minus 8, and then minus 9 when we divide it by a minus 8. Alright, pretty easy stuff if you know what you're doing. Alright, so now it says use the remainder theorem to find the remainder. So just find the remainder. You can do it however you want. Remember, so we can do negative 3, we can do synthetic division as long as we don't forget there's a 0 where there's an x squared. 1, 0, negative 13, negative 17. So add straight down, multiply up, add straight down, multiply up. Add straight down, multiply up, add straight down. Our remainder is negative 5. Now remember, we also could do it with the remainder theorem means plug in negative. Instead of doing synthetic division with negative 3, we can plug in negative 3. So that would have been negative 3 cubed minus 13 times negative 3 minus 17. Let's calculate it and see if we get the same answer. So the bad news is when I type, oh, never mind. When I type it in, I do get it. I get it. We get negative 5. Awesome. Okay, so let's do some story problems here. So remember, this is a dividing test, so there's obviously going to be, our story problems will be division of some sort. So this one says, 3/4 cup serving contains 26 grams of fat. So 3/4 cup is to 26 grams of fat. How many grams of fat are in 3 cups? So set up corresponding ratios. So x over 26 is equal to 3 over 3/4. So then I would go ahead and multiply, solve for x. So I would times both sides by 26. So in my calculator, I would do this. 3 times 26. I'd hit enter. So on top I have 78. Then divided by 3/4. You would want to use parentheses around this. So you'd say 78 divided by parentheses 3 divided by 4. Trying to figure out how to use this stupid smart calculator. So 104. 104 grams of fat. Pretty easy. Set up a ratio of corresponding sides. That's same with that picture of, if you remember the picture of the building and the flagpole, and it's just similar figures here. So it says one pipe can fill a tank in 48 minutes. Another pipe can fill it in an hour and 12 minutes. If both pipes are working to fill the tank, how long will it take? So remember, this is the one where we go, okay, 1 over 48 minutes plus 1 over, now careful, we got to stay consistent. This is hours and minutes. We need to do minutes, period, since this one had minutes, not hours. So 1 hour is 60 minutes, and then plus 12 would be 72 minutes. That's equal to 1 over the time it takes together. So then solve by getting a common denominator here. So I'm going to multiply by 72t, 72t. I'm going to multiply by 48t, 48t. This one's going to need a 48 times 72. Then when solving, we can ignore our denominators. So then we have 72t's plus 48t's, which is 120t's, is equal to 1 times 48 times 72, which is 3,456. So solving for t, I divide by 120. t is equal to 28.8, and that was minutes, because remember we converted to minutes. Nick can fly 180 miles per hour if the wind is not blowing. One day he made the trip 100 miles away directly against the wind, and then on the return trip he was flying with the wind. If the total time it took him was 1 hour and 15 minutes, what was the speed of the wind? Okay, so Nick can fly 180 miles per hour. So this is the distance equals rate and time problem. So the time it took for his trip there, so distance is equal to rate times time. Let's just set up what we do now, sorry. Our distance is 100 and, no. Do we know a distance? Yeah, 100 miles. His rate is against the wind, but we don't know how fast the wind is in this one. So the rate of our wind, we don't know. We know his rate is going 180, but then the wind is pushing against him, so minus the rate of the wind. And then we don't know the time it took him to do that. Now the distance, on the way back, his distance is 100. His rate, now the wind is going with him, pushing him quicker, so he's going 180 miles an hour plus an additional rate of the wind and the time. And then the total time in the end was 1 hour and 15 minutes. So you either need to have it all in hours or minutes. So I'm going to do, once again, minutes just because it's easier to convert in my opinion. So minutes, that would be 60 plus 15, so that'd be 75 minutes. So just remember your answer is going to be in minutes. So we'd probably convert it back to hours in the end. So now you would say the time it took to get there, you divide by 180 minus r, divide by 180 minus r, because then that's the time it took on the way there. So 100 over 180 minus r, and then we're going to add it to the time over here, so divide by 180 plus r. So that's our true statement. So then you'd say, I need to get a common denominator just because that is exactly how we solve equations. So let me scroll up here and give myself some room. Okay, this is over 1, so we would need a 180 minus r, we would need a 180 plus r. This one would need a 180 minus r. (180 plus r), 180 plus r. Ignoring my denominators now. 18,000 plus 100 r plus oh no, we're doing good. Wait a minute. Are we doing okay here? Yeah. And then we have plus 18,000 minus 100 r is equal to, multiplying these three things out, I'm going to multiply these two together first. So I have 75 times 180 times 180 is 32,400. Then I have plus 180r minus 180r. So I'm seeing that those cancel out, so I'm not going to waste my time writing them. Minus r squared. Now I would distribute 75 in. Let's combine like terms on this side. So we now have this, 36,000, our 100 r's went away in this problem, is equal to 32,400, and I'm going to times it by 75, so that's so now you'd say when solving a quadratic, I get its sign equal to 0, so I'm going to subtract this over. Oh, well, I'm just pointing out, sorry, the reason I paused was because, notice, I can just solve directly for r in this one. There's no middle term, so I'm just going to actually do this the easy way. Instead, I'm just going to solve directly for r. So I'm going to subtract this over. Normally, though, you'd have a quadratic that you would factor, but this one, the middle term canceled out. So I'm going to divide by negative 75. So then I get this, 31920 equals r squared. So then I'd square root it. So our r is equal to the square root of that. 178.6. Plus and minus, and then I throw out the minus sign. I'm just feeling weird about this one. I can't think of where I made my error, if I did make an error. Our distance was 100, our rate was 100. Okay, what the freak? Oh. There's no way that's right. If you think about it, the rate of the wind could not be that fast, or else our plane would be going like really slow. I'm thinking what I should have done was left it in hours. So like instead of doing 75, yeah, because it was miles per hour, not minutes per hour. Oh my heck, that's what it is. I converted, I said 75, but what I should have said was 1 hour and 15 minutes would have been, so think about it, 15 divided by 60. That's 0.25, that's 25% of a full hour. 15 minutes is 25%, as you can tell, of 60. So that I should have actually been using 1.25 instead of 75 here. Because I got to stay consistent. It was given in miles per hour, not minutes per hour, you know. So that actually should have been 1.25. And then that would change all this stuff, all sorts, well, just right here. It would have come out better then. Yeah, it would have come out much better. So I'm not going to redo that one. If you're mad about it, sorry. You can come get help one-on-one with me. But really, it's the same calculations, except for it'd be 1.25 times that and 1.25 times r squared. So it just would have, the answer would have been correct. Okay, so we're almost done here. It says the electrical current flowing through a wire varies inversely with the resistance of the wire. So remember that with these, they're actually really easy as long as you know what they mean. So it says varies inversely. So electrical current, I'll just abbreviate, is equal to K, and it varies inversely, so that means divided with the resistance of the wire. So R for resistance. Now it says if the current is 8 amperes when the resistance is 15 ohms, for what resistance will the current be 10 amperes? Now remember, for these type of problems, you'll always solve for K first with the first sentence. So the current is 8 is equal to, or we don't know what K is, and our resistance is 15. So then solving for K would be your first step. So you would do 8 times 15. So K is equal to 120. So now our new formula is electrical, or what was it? Yeah, electrical current is equal to 120 over R. And then the next sentence says, for what resistance will the current be 10 amperes? So this one's giving us, it wants to know the resistance, and then the 10 amperes. Current is 10 amperes. Yeah, so this one wants to know the resistance. So this one wants to know this. If the electrical current is 10 amperes, so I put 10 here. So now I have this statement. 10 is equal to 120 times R. 120 divided by R. So now solve for R. So I'd times both sides by r, and then I would divide by 10. So that gets r alone. So r is equal to 120 divided by 10. So our resistance would be, right, obviously 12. So the first step is to always solve for k, and then they could either give you this or this, and then you just solve for whatever you're not given. So it says the volume V of a pyramid varies jointly. So remember, there's always a k, varies jointly with the base. So that means times the base and the height. So and the height. If the volume of a pyramid is 270 cubic inches, so 270 is equal to k. And when the base area is 80, so 80, and our height is 10, so times 10, it says find the volume of the pyramid when the base area is 125 and the height is 9. So the first step is to solve for k. So I'm going to do 270 is equal to k times 800. So then I divide by 800 to get k alone. 270 divided by 800 is k is equal to 0.3375. So V is equal to 0.3375 BH. And so now I want to know the volume when we have 0.3375. Our base height is 125. Our base area is 125 and our height is 9. So then you just calculate it. That's 0.3375 times 125 times 9. So the answer is 379.6875. That's the volume. So know what varies inversely and jointly means, and you should be set. Remember that k is the constant, and this always works out the same way. They'll ask you to solve for constant first. Well, they won't ask you. You'll just have to know I need to solve for k. Then once you know that, you can just calculate the rest. It'll just be a plug and chug problem. Guys, to prepare for this test, the best way to do it is to practice as much as possible. I know it's a lot of hard work, but there's just no other way to prepare besides practice. And I know you're working hard, and I appreciate it, and you're awesome. Good luck. Remember, I'll be here Monday morning from 6:30 to 7:30.